So, inference batching under constraints. We are building an inference server for an embedding model. Sequences arrive with variable lengths. Each forward pass through the model has two hard constraints: maximum batch size, max number of sequences per batch, and maximum total tokens. Okay. You need to efficiently batch these sequences and process them. First, we are implementing a function that takes a list of sequences, each represented by its token count, and partitions them into valid batches that respect both constraints. Minimize the total number of batches. Now implement the full processing pipeline. Given a list of sequences in a model function, process all the sequences using valid batches and return results in the original order. The model function takes a batch of sequences and returns embeddings for each. Optimize part B for throughput using concurrent processing. Okay, the next batch should be prepared. Implement this using threading or asyncio. Wow, that is cool. That part. I will have to start Googling and searching how to implement this with threading or async input output. That's great. A very good problem. So first of all, let's figure out some of the corner cases and test cases and how this whole thing should work. So here we are just given token counts. So for token counts, it will be, let's say, 1, 2, 3, 4, 5. And then we have max batch size. I'm starting to think about different corner cases. This will be a tough problem because it sounds like a knapsack. So it might be that there is, like, we should use some dynamic programming to solve this efficiently at least. Yeah. What if there are several possible solutions? Can there be several possible solutions? All of those things are not clear yet. So let's say first that our max batch size is 3 and max total tokens is 5. I don't know. Okay. So then we return list of integers, partition sequence indices. Okay. Returns a list of batches where each batch is a list of indices into the original token. Okay. Minimize the number of batches. You may reorder sequences within batches, but each sequence must appear in exactly one batch. Okay. Raise value if any single sequence exceed max total tokens. That was one of the corner cases that I had in mind. Like, what if one specific sequence is longer than the max batch? Okay. So let's say we have 3 and 5. So 3 is the max sequence size. Okay, so yeah, the solution is pretty obviously will be 1, 4, and then 2, 3, and then 5. So this minimizes the number of batches. Okay, let's do the same, but let's say that 4. This will raise value error. I just want to highlight that for myself, because here this sequence is longer than the maximum possible sequence in a batch, like total counts in a total tokens in a batch. Okay, so let's do the same thing, but analyze it Let's say we have 6 here. So can it be more efficient than that? There are at least 2 possible solutions here, right? So this is one solution. We can also use something like 4 and 1, 2, 3. So same number of batches. So yeah, one thing is clear. It is kind of a knapsack problem, but I think it's even more complex than the normal knapsack because it's like a knapsack, a list of knapsacks. So whichever batch we take a particular sequence into, it will impact all the possible batches we can generate. So it's not trivial. And maybe I think in reality there will be some good enough approaches that might not be optimal, but we are getting new sequences, and we also are optimizing for latency. So we would probably just use some greedy approaches to pack everything. But here we want to minimize the number of batches. So how do we do that? Let me create another example over here that would show. Here we are always constrained by the total token size in a batch, and almost never constrained by the batch size. But let's say we have 1, and we have 3 in a batch and 6 the same constraints. In here it will be 1, 1, 1 and 1, 1, just because we cannot fit more than 3 sequences in one batch. So how do we survive both of these thresholds at the same time? Let me think about the solutions, right? Solutions. Like greedy. Sequence by sequence until one of the constraints fails. And that's it. That will be the simplest possible thing. So unfortunately, that's clearly not optimal because, for example, here we could have just packed 1 and 2 and then separately 3 and 4 and 5 if we were going sequence by sequence, and it would be 4 batches instead of 3 batches. So this greedy approach is not optimal. So another approach is one observation is obviously we want to maximize the number of batches that are as close to the constraint as possible, but still under the constraint. So we should basically combine long sequences with short ones so that we fit as many things as possible in one specific batch. I'm thinking in the direction of like binary search on the number of batches. So there will be a number of batches that is possible, and then the number of batches that is impossible. And then we can, like, if it's easier to figure out, like currently we don't even know what is the number of batches. If we define the number of batches, is it possible to use it in such a way that it can be done more efficiently? Then let's try to use dynamic programming. Oops. So dynamic programming. Let's say we use first k elements. What's the minimum batches? So how can it relate to less elements? So let's look at this, right? So we have elements 1, 2, 3, 4, 5. These are our elements. And like as in the knapsack problem, let's say we have a specific total limit in one batch size. So let's say it's 0, 1, 2, 3, 4, 5. So max batch tokens, and this will be element. So minimum batches, let's say if we have, it's like infinity, right? For if we have 0 elements in batch, so how many batches do we need? Minimum infinity. Now here it will be like if we have one batch, here basically the whole column will be infinity, 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 finally infinity. So if we have if we want to use one element and we now have batch size of 1, so only this one element, we have one batch size of 1, then we can use just one batch. But in this scenario it will still be infinity, and again like everywhere here it will still be infinity. Okay, so then Let me just write this so that it's easier. Okay. How do I turn off? I need to turn off double space for dot. Okay, now let's see, we have 2 in just one element. So this will still be 1, and this will still be infinity. But now let's say we have 3. So how many elements, how many batches do we need? 1. But now for this, we also have 1. Why? Because 3 this is what should it be? How much empty space in the last batch? Yeah, I don't know how to solve this yet. I will try to do something simpler. So let's just try to do a smart greedy, which will be sort, use sort at least. Yeah, it's so we want to add if we have a batch size, max batch size of 3, we always want to add 3 elements in such way that the batch is filled. Then we are doing the most efficient thing possible. So how do I do that? How do I achieve that? How do I solve the problem of filling this list without actually going through the whole set of possible solutions? Because it becomes like n sum problem, and for one sum, for 2 sum, or even 3 sum problem, it's the solutions are pretty much known, but for the n sum, it's becoming too complex. So yeah, I will do smart greedy approach with the simplest possible thing, like find the complement, find the So it's like have batches sorted by empty space. Then when a new element comes, find the batch. Yeah, can actually this be beaten? Yes, this can be beaten. So for example, just to give an example of why this greedier approach would not be the best possible one. So let's say we have 5, 2, and then, or let's do simpler, 3, 2, 1, 1, 1, 1, 1, 1, 1. And then we have maximum elements in batch equals to 2, and maximum size of one batch equal to 5. So if we put 3 and 2 together, yeah, so one option would be 3 and 2, then 1 and 1, again 1 and 1, and 1. This is not let's call it incorrect, but correct solution would be something like 3, 1. Oh no, if we have just 2, okay. If we have just 2, that won't be the case. We need to have 3. So in this case, it will be okay. And in 1, let's say we can have 6, right? So 3, 2, 1, 1, 1, 1, and then 1. Oh no, actually this is, let's see. Okay, I cannot figure out. 7 is not a problem. So let's say 7. So here we cannot fit more. Here we cannot fit more. Here, okay. Then instead, do 4. Yeah, I guess I'm not figuring this out now. Let me just finish this. I don't want to spend too much time. When a new element comes, find the batch with enough space. I think I know. 5. Yeah. And 1, right? Something like this. So this is incorrect. But then the correct one would be 3, 1, 1, 2, 1, 1. Yep. Yep. So again, right, we cannot, we need to try to fit both of the constraints as efficiently as possible. Okay, let me ask Claude for a hint. Give me a second. I need a hint for original solution in inference batching. Okay, Claude actually tells me to sort decreasing the token count. So essentially what I already was doing here. And then feed first suitable batch. Yeah, it's an efficient solution. It's not optimal. Maybe two constrained solutions are impossible. So yeah, let's do that. Let's sort by token count, assign to batches not optimal, and also of n log n for sorting. And then yeah, actually keep a sorted list of batches that are not filled yet would be a faster solution, but I have already spent too much time here. Let me just implement this. Okay, so token. Okay. Sequences will be equal sequence I for sorted for I sequence in enumerate token counts. Actually, I have seen that I have quite a few messages already. Let me check what's going on there. Can we use recursion? I'm not sure. What is inference batching? Inference batching is when you want to, yeah, let me maybe copy paste the problem somewhere or something. I don't know how to do that. Let me see if I can just write myself to the chat. So, yep, here is the problem. Maybe I should have sent it right away. Multiple taking input one by one. How will we track which input belongs to which user if we take multiple inputs? Yeah, that's a good question. So that's what I'm trying to do. How do we track which inputs belongs to which user? We just use IDs for each of the sequences here. So let's now do, we have sequences, we have sorted those, but let's sort them in increasing order, but we will be popping one by one. So now batches will be okay, let's do sorted list. So I want to do this. From sorted containers. From sorted containers, import sorted list. You don't have this library installed? I hope you do. Okay, so batches will be sorted list, and it will be empty in the beginning. So then what will be this batches sorted list? It will be, so empty space, then sequence IDs. So yeah, we will be tracking how much empty space do we have left in a specific batch, and then we will also be tracking sequence IDs. So batches, it is a sorted list, and we will be sorting in increasing order. So yeah, we will need to find the batch that has the smallest amount of space that is still enough for us. And if the batch becomes of size length max batch size, we add it to the answer, to the result. Okay, so batches will be sorted list. Now batches bisect or batches find. Let's see how it works. I see 2 more questions. Yeah, machine learning is not just math, but it's also a question whether this is the best example of ML coding. Maybe some other time we will be implementing k-means or something like logistic regression from scratch. But today we are working on like LLM related problems. So we are here, sorted list, find, sorted list, find Python. Okay, no, sorted containers. No, I don't want. Okay, sorted containers. Yep. So now I need to do sorted list, documentation. User right. Okay, finally. Index returns first value, index of value, if value is not present. Okay, that's not what I need. I need basically bisect left. Okay, so here is it. So return an index to insert value in the sorted list. The problem here is that if we have this, right, so we will need to find value for a tuple with an empty list here. Yeah, this is very strange, but okay. So bisect left for count in sequences. So we have batches bisect left. Okay, first of all, if count bigger than max total tokens raise value error. Now, otherwise, we don't raise the error, and instead we find where we should put this specific sequence in which batch. So how do we find this batch? We need to find which batch has enough space. So let's give an example, right? So we'll have empty space, which is 1, and for example, there will be 1 and 3 IDs, and then there will be a batch with empty space 3, and there will be 2 ID. Then there will be a batch of size 5. There will be ID of 4, let's say, and we want to add another ID. Let's also say that it will be 6, just to show that it don't have to be assorted IDs. So now we want to add a new and we want to add this, like we now need to add a sequence of length 2 in the batch. So how do we do that? For count and I in sequences. So we need to add it here, right? So it will return us this particular batch, and that's correct. We want to add it here. So for this batch, we will be, okay. And if it returns us the length of this, that means that we don't have batch with suitable space. We will need to remove that. Okay, so now let's do this. So index will be equal batches bisect left, and we will be adding what? We need space, which is count, and we are just using this for consistency for what we are searching for. So now, if index is equal length of batches, that means that this is the last element. That means that we need to add a new batch. That means that new batch will be equal to what? Max batch size minus count, and it will only store I. And batches and new batch. Unless, okay, if, oh no, max total tokens here. If max batch size is equal to 1, else this. So if it's equal to 1, we just need to add result. Let's enter that. So if max batch size equals 1, then for count in token counts, if so here what I'm trying to do is, like, if we always can add just one element to the batch, let's write this corner case in the beginning, and don't process it later on. Result and for I count in token counts. So here I will be returning result append I, and eventually we will be returning result. So this is a corner case. We don't want to process that. Let's process this thing instead. So batches append new batch. And here we now are guaranteed to have at least several possible elements that we can add, several sequences that we can add to one batch. So now max batch size is never 1. So now if max this equals 0, then we just add result append I. Else batches append new batch. Okay, so if there is no empty space in this batch, we just append it to the result. Otherwise, we append it to our list of batches. Okay, now we do that. We find it. Now, if index is equal to length of batches, so this is when we are adding new batch. I will do it differently. So this is the batch that we are creating in this case, and then else batch equals batches index and batches remove. How do we do removal? For sort at least discard remove value. Okay, basically. So I cannot just remove a specific index, right? Yep, okay. Then I will be removing the specific batch. So remove batches index. So here we go. We have created a new batch. Now we know that we can add element to this batch. So we do batch equals, so batch 0, this is the space, the empty space, minus count, and now sequences is currently batch 1, so all sequences append all sequences append I, and now the batch will be batch 0 minus count and all sequences. And now we need to decide what to do with this batch. If or length of batch is equal to max batch size, then we are just appending batch 1 else we are, so either we are putting it to result or we are putting it back to the batches. Okay, now finally for batch space batch sequence in batches, we do result append batch sequence and return result. Yeah, this is it, and this is also very ugly. This is very complicated. Even with the simple solution that is a greedy one, which is not an optimal one, it's still crazy complicated. Let me see what people are writing. Yeah, it's kind of DSA byte for ML. Yep. Well, if you think that this thing is nice, thank you. What are the other problems like this in AI? Damn. This is, as others have mentioned, not really like an AI problem, but it's something that you should be able to solve. And something that everyone is solving. So just to give you a context, whoever is watching this, right? When you're training your large language model, then you have deployed it, and then the problem is that there is a trade-off. So the bigger the size of the batch that you're trying to process simultaneously, the more efficient it is for you, as long as you can feed the whole batch. But the latency grows because what happens is your request comes to LLM provider, then my request comes to LLM provider, then your friend request comes to LLM provider. It batches all of those requests until it's big enough that it can send it to GPU to process. Because if it sends to GPU a shorter request, a smaller batch, then it will be GPUs won't be loaded efficiently, and you will be kind of like wasting some cycles. So then you need to fit as many things as possible into one batch and send it to GPU. The problem here would be that in reality, you will mostly do that by using cutoffs. And yeah, there will be some logic that if you get a new sequence that is especially long, you will probably put it on another batch, but it's relatively rare. And you will be optimizing for different things. You will not be optimizing for the minimum amount of batches. In a way you will, but you will be fine with some approximations. I think like the approximation here. Yeah, that's why it's close to the real world, but in the same, in the reality, this is more of the software engineering than ML engineering, because yes, this is part of the system that you're building for your large language model inference, but also it's not something that is using math in any significant way. It's just software engineering. Okay, let's go back here. I will just run the tests. I'm pretty sure that something is broken here. Okay, so no module names, sorted containers. Sorted containers. Okay, sorted containers is not installed in GCP. Can I install it? Pip install sorted containers. Okay. Are you working now? Yes, you're working now. Great. So now I just need to remove this cell so that I can also remove this cell and can run the tests. Okay, not implement. I need to use add, not append. Batches, all sequences, batches, add. Because it's, yeah, it's more like set than like. Okay, all tests for A are passed. Wonderful, nice. We actually have implemented this. I think, okay, tests are not exhaustive. Probably there is some issue somewhere here that I'm not thinking about, but let's now go to part B. So we have sequences, processor sequences from model function and valid batches, return embeddings in the same order as the input sequences. Okay, so sequences, max batch size, max total tokens, and I'm returning. Okay, this is relatively easy. So length of sequence for, how do we call it here, just for consistency, token counts. Let's do token counts, then sequence for sequence in sequences. Nice. Then we are doing batches, create batches, token counts, and then max batch size and max total tokens. Okay, and at the same time okay, now we just need to do batches. We have at least like 1, 2, 3, 5, and 4, right? So this is our batches, and we now need to output the results in embeddings. So for, okay, what's model function? A list of sequences, list of floats. Process all sequences, return the results. Do I have an example of how this will be working? Callable list of sequence, and it will return. Okay, I think I will just need now to do for batch in batches. Okay, yeah, it's actually easy. Answer will be none times len sequences. So for batch in batches, what we do is we do embeddings will be equal to model function that is processing our batch, and then for I an embedding in zip batch and embeddings, answer I equals embedding, return answer. So what is the input? Test per B sequence. Okay. Oh, it's actually, yeah. So we have length implemented specifically. So it's not that. So sequence is not just any sequence, it's a specific object. Sequence length. Okay. Int object is not called. Oh, it's attribute. Okay. It's not a method. It's basically an attribute. Oh yeah, I think I also need to pass. Okay. So batch sequences. Yeah, that was a bug. That is a serious bug that I should have understood better how this whole thing works, but yeah. So for this we will have to do sequences I tokens. Oh no, it's just sequences I for I in batch, and this. Okay, test B all test passed. Nice. Now finally part C. Same as process sequences, but with concurrent batch preparation and model execution. While batch n is being computed by model function, batch n plus 1 should already be prepared and ready. Okay, let's see. So thread pool executor, threading, input time. I have no idea how this should be implemented in Python, but let me just have an idea here. So, okay. The problem is, right, we are creating this sequences, but then we also need to send it in a separate thread. So, so essentially we will be doing sync promise await promise so we will need to create like threading thread, and essentially this will be sync def. Okay, sync def await. So we are creating a thread and we are putting our relation there, and then we will be retrieving it. The results will be like here it's just a promise. So actually I think let me define another function. Sync def process Yeah, we need, I need to remind myself of how this whole thing would work in Python. I understand the conceptual thing, that we need to send it in the thread and continue executing here. Then for the promise, we need to actually retrieve this data finally, like after it's already calculated and put there. So then after that, we need to process it in this way, and we can just put those promises all in some pool. So promise pool will be this. So promise pool append promise and then for promise in for I promise in promise pool yeah, we will need to also put promise pool append batch. Okay, they will be put together. So promise batch promise in zip matches promise pool. I embedding will be embeddings will be promise sync, so something like this. So essentially we finally here are running our blocking evaluation. We hopefully already get our promise. We can finally calculate it here and we will return the results. So this is not how things are working. Now I will figure it out offline. Well, what am I creating? I was writing a very complicated problem for LLM inference batching under constraints. Now I have finally finished it mostly, and it has highlighted a lot of blank spots for me, so I will now go and check offline how it should be actually done. And thanks everyone for watching who was watching. See you tomorrow in the next one. Tomorrow we will be doing yet another stuff like that. But after a few more days, I will be doing more normal